Hello and welcome to another digital design class. In the previous class, we learned about 3 variable K-maps and 2 variable K-maps and how we can use the K-map or Karnaugh map to simplify a Boolean function. Today we want to continue, we will continue with the 4 variable K-map and 5 variable K-map. And if we have time, we will continue with the prime implication and also the don't care situation as well, where if we have time, the complement, the De Morgan's law, and so on. So without further ado, let's start with 4 variable map. We learned in a 3 variable map, and we solved some practice problems. When we have 3 variables, we would have 2 to the power of 3, 8 squares. And each square gives us one minterm. We start with M0, then M1, M3, M2, M4, M5, M7, and M6. And then we can combine them. We can combine them in a pair of 2, 4. We can have 1, 2, 4, or 8, or so on. And therefore, we can simplify it. And we solve some practice problems as well. If we have a 4 variable map, we would have 2 to the power of 4, 16 squares. Okay. We will start with M0, M1, M3, again M2, M4, M5, M7, M6. And then we would jump 1 row to M8, M9, M11, and M10. Then we will go back to M12, 13, 15, and 14. So as you can see, the upper 2 rows looks exactly like the 3 variable K-map that we had here. And we add 2 other rows. And an easy way to actually memorize this is to remember that in a 3 variable K-map, we switched the 4th and the 3rd column. Therefore, we had M0, 1, 3, 2, 4, 5, 7, 6. And we do it here as well. The 4th column and the 3rd column are switched. And we also switch the location of the 3rd row and the 4th row as well. So it goes like M0, 1, 3, 2, 4, 5, 7, 6, and then 8, 9, 11, 12, 10, 12, 13, 15, and 14. Again, we can have a combinations of 2, 4, 8, and 16 adjacent squares. The squares which are at the end could be paired. So for example, I can pair M1 and M0 and M2. And I can also pair M8 and M10. And I can also pair all 4. So I could pair M0 with M2, with M8, with M10. I can also pair, for example, M4 and M12 with M6 and M14. So as you remember, for a 3 variable, it looks like a ring. And imagine that both of them are adjacent to each other, M0 and M2. So imagine this is in a 3D situation, and M0 and M2 are also adjacent. Now, to show the variables on the map, very similar to the 3 variable system, if we have W and X on the rows and Y and Z on the columns, the 2 columns on the right are going to be Y, so therefore this would be Y prime. The 2 columns in the middle would be Z, therefore these 2 would be Z prime. 2 rows at the bottom would be W, so the first 2 would be W prime. And the the middle 2 rows are going to be X, therefore the other 2 rows are going to be X prime. Is it clear? Can I go to an example so we can solve an example, learn it? Yes? Okay. So the first example, we want to simplify f of w, x, y, z, which is sigma of 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, and 14. So 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, and 14. And the rest is 0. So M3 is 0, M7 is 0, M15 is 0, M11 is 0, and M10 is. And in most cases, we don't even write zeros because we don't need to even write those zeros. But this is our table. And we want to simplify f of w, x, y, and z. Again, M0 for this, it's the sum of products of the min-term of it. It's x prime, y prime, z prime. W prime, x prime, y prime, z prime. And for example, M15 is w, x, y, z. I will give you a few minutes to think on it, and then I would solve it. Okay. Does anyone have the answer? Yes? Do you need a few minutes? Okay, I'll give you a few. Okay. So we want to maximize the number of ones that we can pair first. So I would pair all these 8 ones. So, and we already know that this is y prime. This is w. This is z and x. So these 8 ones would create y prime. So f would be equal to y prime. And for these two, I want to maximize again the number of ones that I can pair together. So I'm going to pair these 2 ones with these 2 ones. And if I pair them together, I'm going to draw it with green. And this is going to be plus. What are these 4 ones equal to?
X, Z prime.
Perfect. Thank you. It's going to be x, z prime plus. We have one left. Okay, I can write it as w prime, x prime, y z prime, but that's going to be inefficient. We're going to add a lot of gates to it. So the best thing to do is actually to combine it. I can combine this with this, so I have a pair of 2, but a better option even is, let me do another color. Let's say, I don't know, yellow. Better option is to combine these 2 ones with these 2 ones. And the yellow one would be equal to what? It's going to be equal to w prime z prime. So it's going to be y prime plus x z prime plus w prime z prime. So, and by the way, sometimes we don't have a unique answer. We may have multiple answers, and all of them are correct. And I'll show you some examples on that as well. So y prime plus x z prime plus w prime z prime. You can see it. We have here. Is it clear? Okay. Let's solve another one. Let's simplify the following Boolean function. F is equal to sigma of 0, 1, 5, 7, 5, 7, 8, 9, 2, 10. So it's going to be 1. I didn't write it in order, but yeah. So sigma of 0, 1, 5, 7, 8, 9, 2, and 10. I'll give you again a few minutes to think on it, then I would start. Did anyone solve it? Do you want me to? Does anyone have the answer? Do you need more time? Okay. Again, the first person to solve this gets extra points on their homework. M0 is 1, M1 is 1, M8 is 1, M9 is 1, M10 is 1, and M2 is 1. Also M5 and M7. Okay. Am I correct? 0, 1, 2, 8, 9, 10, and 5 and 7. Yes, what's your question?
So you can pair from one side to the other. Are you
Yes.
able to do that top to bottom?
Yes, as I mentioned, you can do all 4 corners. Yes. So imagine it's like a, you know, globe type of thing. 0 and 8 and 2 and 10 are also adjacent. Okay. So you can combine all 4 in the corners because again, M2 is actually adjacent with M10, M3 is adjacent with M11, and this is M9, and this is M8. And the same thing on the sides as well. Like M0 is adjacent with M2, M4 is adjacent with M6, M14 is M12 is adjacent with M14, and M8 is adjacent with M10. Okay. I want to erase it because I don't have enough space to write down. So I can do all 4 in corners. And if I do them, I combine them, I would have, again, this is W, Z, X, and Y. So if I combine all 4 corner ones, what do I get? I would get X prime, Z prime. So F for the red one is going to be X prime, again, because these are X prime, these are Z prime, and Z prime. Plus I can combine these 2, but the better way to do it is actually combine these 4 together. So these 2 and these 2, if I combine it, so to cover that one. If I combine these 4 together, I would have, again, X prime, Y prime. And then I'm left with these 2. I cannot combine them. So if I combine the one on the left, M15 with M1, then even M17 would be left alone, and we won't we don't want to do that. So I'm going to combine M17 with M7 with M5. And if I combine these two, the green one, I'm going to write it with green, is going to be equal to X W prime, or W prime X. I want to write it in the same order that we have them in terms. So it's going to be W prime X. So F is going to be X prime Z prime plus X prime Y prime plus W prime, again, because this row is in W prime and it's in X. So it's going to be W prime X. Do you want me to solve another one, or? Yes? Okay. Let's solve one with a proof. I have another example with proof here. So this example, we want to simplify F of A prime B prime C prime plus B prime C D prime plus A prime B prime C prime D prime plus A B prime C prime. So this is doing it the other way around. If we want to use Boolean algebra and Boolean functions, we can write it like this. A prime B prime C prime D prime plus A prime B prime C D prime gives us A B prime D prime. And A B prime C prime D prime plus A B prime C D prime gives us A B prime D prime. And A prime B prime D prime plus A B prime D prime gives us B prime D prime. And A prime B prime C prime plus A B prime C prime gives us B prime C prime. And we can use these theories and postulates to be able to solve it. And you can see it's going to be very, very difficult. But let's try and solve it using just a K-map. So if I want to use a K-map, first part F is A prime B prime C prime. Okay. So if, for example, this is A and this is B and this is C and this is D. So A, B, C, and D. This would be A prime. These two are D primes. These two are B primes. And these two are C primes. Now, first part, A prime, B prime, C prime. A prime, B prime, C prime. A prime is going to be in the first two rows. B prime is going to be in the first row. So A prime, B prime, and then C prime. So I'm going to be left with these two. So A prime, B prime, C prime are these two. Next one, I'm going to do a different color. B prime, C, D. So B prime, and it's going to be in C and in D. So B prime, C, D. It's going to be these two. Let me see if this is a different one from the other one. So B prime, C, D. Oh, C, D prime, not D. Sorry. B prime, C, D prime. So B prime, C, D prime are going to be the twos on the right. And the next one, I'm going to do it with red. A prime, B prime, C prime, D prime. So A prime, B prime, C prime, and D prime is going to be this one over here, because it's an A prime, and an B prime, and an C prime, and an D prime. And finally, I have A, B prime, C prime. A, so it's going to be two bottom rows. B prime are going to be the last row, and C prime is going to be these two. So I'm going to have these two. So I'm left with M0, M1, M2, M10, M8, and M9. Have I missed anything? I think I'm missing one, but A, B prime, C. Just give me 1 second. I want to double check it. C, B prime, C, D. Prime, B prime, C, D prime. And then A prime, B prime, A prime, B. Okay. Well, it seems it's right. So if I want to combine them, I can combine these four together. Let me do it with a different color. I can combine these four together. And then I can combine these two together. These two ones. So these four. So for the blue one, it's going to be equal to D prime, B prime. The blue one is going to be D prime or B prime, D prime, plus the green one is going to be equal to C prime, B prime, or B prime, C prime, you know. So B prime, C prime plus B prime, D prime. Now let's check the answer. Yeah, did we have a prime, C, D prime? Yeah, this one probably is a typo because we don't have an A prime, C, D prime. So if you scratch this one and I don't see an A prime, C, D prime, you're gonna see no, we don't have an A prime, C, D prime. So it's gonna be, if we had, it's gonna be that one combined to it. And if we simplify all of that, we're gonna reach again to B prime, D prime plus B prime, C prime. If we had a plus A prime, C, D prime here, then this would be the answer for that. But for the previous question, we didn't have an A prime, C, D prime, so the answer would be F is equal to B prime, C prime plus B prime, D prime. So in your notes, make sure that you correct this typo. Now, prime implicants. So in prime implicants, all the min terms are covered. We want to minimize the number of terms. A prime implicant is a product term obtained by combining the maximum possible number of adjacent squares, or in other words, combining all possible maximum numbers of squares. And the essential prime implicant is a min term, in that a min term is covered by only one prime implicant. And the essential PI or prime implicant must be included. And I will explain more about that. This is an example of a prime implicant. One thing to keep in mind, and one important note, is that sometimes the simplified expression may not be unique. You may have 3 or 4 answers, and all of them can be correct. Okay. This is an example of F is equal to sigma of 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, and 15. And again, as I mentioned, we want to maximize the number of adjacent numbers that we want to put together. So if I had a 1 over here, let's say I had a 1 over here, I would like to combine all these 4s together. And by the way, I can't combine 6 together. It must be the pair of 2, 4, 8, 16, 32. Okay. If I could, I would combine the 2 on the top with it as well. But if I had just 1 over here, I would like to combine it again with other 3 adjacent ones. Now for a 5 variable map, in a 5 variable map, we would have 2 in a power of 5, 32 squares. So it's going to become a 3-dimensional problem. If we add 6, it's going to be 64. 7 is 128. We would have 2 identical maps. In one, A is 0, and the other one, A is 1. But B, D, C, and E are exactly the same on both of them. And the way we will write the midterms is going to be M 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10, exactly like the 4 variable map. And then we will continue with 16, 17, 19, 18, 20, 21, 23, 22. Then we would jump 1 row, 24, 25, 27, 26, 28, 29, 31, 32. Again, you can see that these 2 columns and these 2 rows are being switched. So easy way to memorize it is like this. And the arrangement of B, C, D, and E are the same in both of them. The only difference that it is, as I mentioned, on the right one you have A is 0, the right one A is 0, the left one, sorry, the right one A is 1, and the left one A is 0. So again, arrangement of B, C, D, E are the same on both of them. But the only difference is the right table has an A of 1 and the left table has an A of 0. Now, let's solve some examples. Let me copy this so you would have it. And let's solve some practice problems. Let me finish this table and then I'll go to the practice problems. So this table shows the relationship between the number of adjacent squares and the number of literals in the term. So for example, if we have 0, which is the number of adjacent squares would be 1, 2, 4, 8, and 16 and 12, and the number of the k would be 0, 1, 2, 3, 4, 5. And as I mentioned, if I have, for example, and I showed this in the previous class, if I have, for example, in a 4 variable system, if I have 8 squares adjacent, I would have only 1 variable. If I have 4, I would have 2 variables. If I have 2, I would have 3 variables. If I have 1, I would have all 4 variables. Let me go back and I would give an example to you. So imagine here, if I only have 1 bit, 1 bit would be W prime, X, Y prime, Z. I would have all 4 variables, yes? Now let me draw the second with red. What if I have 2 variables? If I have 2 variables, then I would have Z, X prime, W, or W, X prime, Z. So I have 2 variables, but how many, 2 bits, but how many variables do I have? 3. Now, what if I have 4 variables? 4 ones, 1, 2, 3, 4. How many variables would I have? So the blue one would be equal to X prime, Z prime. I would be left with 2. And if I have 8 of them, so imagine 1, 2, 3, 4, Let's do it with a different color, green. 1, 2, 3, 4, 5, 6, 7, and 8. Then I would be left with one variable, and it's x, which is one variable. What if all of them are 1? What if every single one of these are 1? Yes, f would be 1, so I'm left with 0 variables. Okay. So the more the number of adjacent bits, I would have less variables in the equation. So this table just indicates that for n equal to 2, 3, 4, and 5, this is a number of literals in a term in an invariable map. Now, technically, a 5-variable map looks like this. You have 2 maps on top of each other, and they correlate. And the upper one is A0, the lower one is A1, and the D's, C's, E's, and B's are shared among both of them. Now, let's solve a practice problem. Just give me a second. So imagine we have a function of f, which is equal to the sigma of 0, 1, 2, 3, 4, 5, 16, 17, 18, 19, 30, yeah, this is enough for the first example. So f is sigma of 0, 1, 2, 3, 4, 5, 16, 17, 18, 19, 30. Let's add another one as well. Let's make it 15 and 30. Or 14 and 30. That's going to be better. 14 and 30. So 0 is 1, 1, 3, 2. We have 4 and 5. We have 16, 17, 19, and 18. And then we have 14 and 30. I'll give you again a 4 minutes to think on this. Does anyone have the answer? So I can combine these 4 together, and I can do it with these 4 as well. So if I combine both of them together, they share the same A, so A would be out of the picture, and then I'm left with, by the way, this is C prime, and I have again, C prime and B prime. So it's going to be B prime, C prime for the red one. And I have these two blue ones. It's better to combine them actually. So I'm going to combine these 4 together. And for these 4 blue ones, A is 0. So it's going to be A prime. And then we have B prime and D prime. And then finally we have these 2 green ones that we can combine together because both of them have a C in common and they have E prime. So it's going to be A, B, oh, I'm sorry. Yes, A, B. A is common between them, so we don't need to write the A. So it's going to be B, C, D, E prime. Let's solve another one. Did you write that down? Now, the next one, we want to simplify f is equal to 0, 1, 2, 4, 6, 9, 13, 21, 23, 25, 29, and 31. Does anyone have the answer for this? So these are the ones that we have in the table. We can combine these two with these two. We can combine these two together. And we can combine it with these two. So these are actually combined together. And finally, we can combine these four together. Let me draw this one with a different color so it won't confuse you. So this is going to be the blue one is set, the red one is one, the black one is in another one. So for the blue one, we would have A prime, and it's going to be equal to B prime, E prime. So A prime, B prime, E prime are the blue ones. And for the red one, we're going to have A, C, because it's in the C, and it's in the E. So A, C, E. And for the black one, we're going to have B, D prime, E. And it's because it's shared in A and A prime, we get rid of A and A prime. So this is how we combine them, and this is the results. And this is another form of the map. Let me solve another one. Give you another example. You're gonna most probably see a 4 variable in your FE exam. So that's the reason I'm gonna solve another one as well. So F is sigma, or let's solve it another way. F is equal to xy plus wx y prime z prime plus w prime x prime y prime z plus y prime z prime. Let's add another part as well, plus w prime z prime. I want to make it so it becomes much more simplified. So xy plus w x y prime z prime plus w prime x prime y z y prime z plus y prime z prime plus w prime z prime. Does anyone have the solution? Okay. Let's map the function first. So xy, it's going to be part of x and part of y. So it's going to be these four. And because it's two variables, you're going to have four ones in the system, or four min terms. Then w x y prime z prime, you can even find it. W x y prime z prime is this one. If we want to write it down, it's going to be equal to 12. It's 1, 1, 0, 0, which is 12, so M12. Then we have w prime x prime y prime z, which is going to be 0, 0, 0, 1, which is 1. Yes, it's going to be M1. And then we have y prime z prime. So y is this is y prime, and this is z prime. So we're going to have all these four are going to be y prime z primes. And finally, we have w prime z prime. So w prime is going to be the 8 squares on the top, or these two rows, upper rows. And then we have z prime. So we're going to have the two columns at the end. So it's going to be this, 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 and this. So it has an overlap technique. Now to combine them, combine these four. I can combine these four. I can combine, and by the way, it may not have a unique answer. You may have 2 or 3 answers depending on how you combine them. I can have these two or these two.
Does it have to be connected in 4s or 2s?
It must be 4s and 2s. It can't be 6 or 7 or something like that, or 2, 4s, 8s, and so on. So the red one is going to be equal to y prime z prime again. If we wanted to make it a little bit more interesting, I could have added another one here. I could have added, let's not change it, but if I added this one over here in the corner, it's going to be much, much simpler. But for this one, it's going to be y prime z prime plus, f is going to be y prime z prime plus x prime w prime x prime w prime x prime y prime plus, which are these two? These four are going to be x, y, and the two in the right corner are going to be equal to y, z prime, w prime. So w prime, y, z prime. So we went from 5 to 4, simplified a little bit. But you can see that these terms we have simplified at least one gate and one entire term. Okay, that's it for today. Next week we will continue with the product of sum simplification, or the max term, and the De Morgan's law, and so on. Thank you so much. And we're going to go straight to the lab to continue with lab number 2 today. Thank you.